Hello, Assalamu alaikum. This is Ishan Akbar. In this video lecture, I am going to derive a relationship between dry unit weight and wet unit weight of the soil. We mostly denote the dry unit weight by gamma D and wet unit weight by just gamma. So, in this lecture, we will derive relationship between these two. This is the lecture 14 of the Geotechnical Engineering series. To start with, we just need to know two basic quantities or three basic quantities, you can say. In last lecture, in lecture number 13, I discussed the volume ratios for porosity and void ratio and their relation with each other. In this, we will see that there are three components. First component is the solid, next component is the water, and last component is the air. This is the three phase diagram of the soil. We have three phases available in the soil mass. So basically, the volume is occupied by all three phases. We have volume of solids, volume of water, and volume of air. But when we are considering the weights, we will just consider the weight of solids and weight of water. We will just ignore the weight of air. We will approximately take it equal to zero. This is just an approximation. In reality, there may be some weight of the air in the soil sample, but here we will take the approximation that weight of air in a soil mass is equal to zero. So to start with the weights, Ws is the solids weight, Ww is the water weight, and W is the soil weight. So in volume we have five terms, that is total volume, voids volume, solid volume, water volume, and air volume. But in case of weight, we just have three terms: total weight, mass, weight of the soil mass, weight of solids, and weight of water. So now, if we relate these terms with volume or with uh, their own quantities of weight, so first term which we will get is the water content. You can say it as the water content or simply moisture content of the soil. This is denoted by small w, or you can take any symbol for this value. So we have two weights, weight of water and weight of solids. So water content is basically the ratio of weight of water to total weight of solids. If you multiply this by 100, it will give you the percentage, and if you want it in fraction, then it will be just WW over WS. It means the ratio of water weight to the weight of solids is known as the water content of the soil. Now, the second property, by considering the weight and volume of the soil sample, is the wet unit weight of the soil. This is denoted by gamma. So, wet unit weight of the soil is simply the weight of soil sample. Uh, let us say you have got some soil sample from the field, and you want to determine its wet density or in situ density. This is also known as the in situ density, mean in field density. So we will simply determine the weight of the soil sample and will divide by its volume in whatever container it is taken. So this is basically the moist or wet unit weight of the soil, or in situ or in field unit weight of the soil. Total weight, this one, to the total volume of the soil sample, this one. So the third quantity in this series is the dry unit weight. Here you can see by name dry unit weight of soil. This is denoted by gamma D, and this gamma D is found by the total volume And what does the dry mean? The dry only means we have only weight of solids in our soil sample. So weight of solids to the total volume of the soil sample. In dry condition, we just have solids in soil. We will have no water. There will be air, but we normally ignore the weight of air. So there will be only solids in dry form of the soil. So now our basic task of this video or this lecture is to derive the relation between gamma and gamma D. For this, I will write down the formula of gamma, that is equal to total weight of the soil sample divided by the total volume. So what is the total weight of the soil sample in form of components? So this W comprises of two components, weight of solids and weight of water. So you can write it as weight of solids plus weight of water divided by total volume of the soil. So what will we do? We will simply divide the numerator, sorry, this is WW by WS, and same we will do for the denominator, WS. So what will happen? This WS will be divided by both terms in the numerator. It will be WW over WS divided by V over WS. So this WS will be cancelled. So we'll get W gamma is equal to 1 plus, what is WW over WS in fractions? So going to the last slide, WW over WS is equal to water content. So you can just write here as small w for water content divided by V over WS. So simply, if we rearrange this equation, it will be like this: 1 plus W into WS over V. When it is being divided, it is V over WS. When this term will be multiplied with this one but plus W, it will be inverted like WS over V. So what is WS over V in our case? Weight of solids over total volume of the soil sample is the dry unit weight. You can say that gamma is equal to 1 plus water content into gamma D. This term, this term is equal to dry unit weight of the soil. So we can simply see that there is a direct relation. If the dry density of the soil increases for a fixed moisture content, it means its moist or wet density will also increase. So we can simply say gamma D, or we can rearrange for gamma D, gamma over 1 plus W. If you are going to take the dry unit weight of any soil, because you can easily determine the gamma in field or in situ density or in situ unit weight of the soil, and you can also easily determine by oven drying this W. Here you will put the value of W in fractions, not in percent. You will put in fraction at, let us say, value of W is 29%. It means you will put 0.29 in this value, in this place. So this is the relation between dry unit weight and wet unit weight of the soil. If you are going to derive a relationship between the dry and wet densities, what will be the relation? So the relationship will be simple. So gamma is equal to density into gravitational acceleration. You will simply put the values for gamma d. This will be equal to rho d into g, equal to gamma bulk is equal to rho into g divided by 1 plus w. This g will be cancelled with this one. So what will be dry density is equal to wet density over 1 plus w. So this relation is between the dry unit weight and wet unit weight, relation 1, and relation 2 is between dry density and wet density. So this is all about the this video today. See you in the next video soon. Take care. Allah Hafiz.